tomorrow, Friday. Okay? All right? So test coming up this week, Friday. Okay? It will cover 3 major topics. First topic it will cover is converting of angles. Okay? So converting angles, degrees to radians, radians to degrees, radians to degrees, minutes, seconds, degrees to degrees, minutes, seconds, degrees, minutes, seconds to decimal degrees, all different kinds of converting of angles. Okay? Second topic it will cover is it will cover S equals R times theta. Arc length equals the radius times theta as long as theta is in radians. Okay? Okay, so that's the second one that we'll cover. Third one it will cover is circular motion, which is your speed chart. Okay? So get to know your speed chart. It will not be on the front board like it is right now on Friday. Okay? Okay? And no, you do not get a note card for Friday. Okay? Get to know it. Okay? Feel the need for speed. Okay? That's what I'm not done. But you'll see that later. Okay? All right? Good? Fantastic. All right, so tweaking a little bit today. Today we're going to deal with 2 circular objects that are being driven by a chain, like on a bike, or a belt on a motor, or a rope on your, like if you think back, there's some old-fashioned, like if people have a second floor window, they've got a couple of pulleys and they got a clothesline that goes outside, okay, kind of a deal. That's what we're dealing with today. Okay? We're going to deal with this kind of circular motion today. Okay? So, I just want to make myself some more space because I like the space. Okay? So, when you're thinking about it, you're thinking about 2 separate circles that are connected somehow. Okay? And so if you're thinking about 2 separate circles, like this picture up here, okay? If you're thinking about that, what's constant between those 2 circles? So I've got one little spinning thing, or if you think about if you're riding a bike, and you think about your bike chain and the front sprocket and the rear tire sprocket. What's constant? The ratio between the gears. The ratio between the gears, okay? But like in terms of speed, I should have instead of saying what's constant, in terms of speed, what's the same on both? Which speed is the same on both? Angular, rotational, or linear? Give me another chance. Linear. Linear is the same. That belt or that chain is always moving at the same speed, no matter where you are on that belt or on that chain. Okay? For instance, this picture right here. Okay? This belt is not going to speed up around this pulley without having to speed up around the other one. You know what I mean? I can't go faster on this side and slower on this side. The belt has to move because it's one belt. Okay? It has to move at a continuous, constant rate. Okay? The other 2 vary. Okay? So it's the other 2 that vary. So the belt on an electric motor connects metal wheels with radii of 2 inches and 5 inches. The rotational speed of the larger wheel is 120 revolutions per minute. Okay? So we want to find the angular speed of the larger wheel in radians per second. Well, the large wheel is moving at 120 revolutions per minute. I want to get that into radians per second. What do you want to tweak first? Revolutions or minutes? Neither one of them shows up in the other one. What do you want to tweak first? Radians? Yeah. Okay, all right. So how many revolutions or how many radians is one revolution? 2 pi. So gone are my revolutions. So now I'm in radians per minute. What do I want to be in?
Radians per second.
Radians per second. So I need to change minutes. How many minutes are in a second, or how many seconds are in a minute? In 1 minute. So we're going to go 1 minute on top and 60 seconds on the bottom. And now the only labels that I have left are radians per second, correct? Okay. So we can do some maths now. We can multiply across the top and we can get 240 pi. We can multiply across the bottom and we can get 60. And then we could divide 240 pi by 60. Or we could say that 60 goes into 60 once and 60 goes into 120 twice. And that leaves me with 4 pi radians per second. Okay? Now, logically thinking, if the motor is spinning at 120 revolutions per minute, that means it's making 2 revolutions per second, right? Each revolution is 2 pi, so if I'm going around twice in a second, I'm going 4 pi radians per second. Good? Okay. What is the linear speed of the belt? Well, we know that the larger, we were on the larger one. We know that the large wheel was spinning at 120 revolutions per minute, or 4 pi radians per second. Okay. I want that to be a linear speed in inches per second. So what is the radius of the larger wheel? 5 inches. Okay. So that's going to be 1 radian is 5 inches. And now I'm in inches per second, which is I'm traveling, or the belt I should say is traveling at 20 pi inches per second. Agree? Now it's asking me for the angular speed of the smaller wheel in radians per second. Well, I know that the belt is traveling at 20 pi inches per second, and both wheels, because both wheels are connected by the belt, both wheels then are traveling at 20 pi inches per second. Okay? So we need the radius of the smaller wheel. The radius of the smaller wheel was 2 inches. Oh, come back. So 2 inches is 1 radian on the smaller wheel. That puts me in radians per second, which then gives me, this is traveling at 10 pi radians per second. Logic tells us that if linearly they're both traveling at the same speed, the larger wheel angularly would be not spinning as fast, right? And the smaller wheel, because it's got to go the same distance but it has less distance to go, has to spin faster, right? So my larger one spun at 4 pi radians per second. My smaller one is spinning at 10 pi radians per second. So that little one is spinning much faster. Okay? What I would like you to do now is I would like you to attempt this particular problem. Go. So, we've got a large pulley and we got a small pulley. Okay? I know that my small pulley, because it's only a 4-inch diameter pulley, is operating at 1450 revolutions per minute. So the small one is working at 1450 revolutions per minute. I want that in radians per minute. 1 revolution is 2 pi radians. Revolutions gone, leaves me in radians per minute. So the small pulley is operating at 2900 pi radians per minute. Do we all agree on that one? Yep. Okay. All right. Now I've got to find the angular speed of the large one, or of the saw arbor. Okay? So the small one was the motor, the large one's the saw arbor. Okay? So the small wheel is spinning at 1450 revolutions per minute, which gets multiplied by 2 pi radians for 1 revolution. And 1 radian, now remember I'm still on the small wheel, What's the radius of the small wheel? 2 inches. So all of this was to get me the linear speed of the belt. Okay? So that's how fast the belt is going. Right? Now that belt is traveling from off of the small wheel to the large wheel, right? So now that's the linear speed of the large wheel. Correct? So I can turn that linear speed back into an angular speed by figuring out what the radius of the large wheel is. What's the radius of the large wheel? 4.5 inches. And that leaves me with radians per minute of the large wheel. Well, if I do this math, I get 1450 times 2 is 2900, times 2 is 5800 pi over 4.5. Mathematically speaking, what's wrong with that fraction? There's a decimal in it. We don't like decimals in it. So I could multiply by 10, top and bottom. That would get rid of the decimal. Or I could multiply by 2, top and bottom, and that would get rid of the decimal. If I multiply by 10, I would have to reduce. If I multiply by 2, I don't have to reduce. Now, I am giving you all of these answers today in exact form because we are not done with this problem. We're still going on with this problem. Don't round until the very end. When you're done and you're writing stuff on an answer blank, or if you're ready to box an answer, then you can round or you can leave it exact. Okay? All right? But because now we're going to find the speed of the saw. That's the large one. Small was motor. Large was the saw. In revolutions now per minute. Well, the saw is spinning at 11,600 pi radians every 9 minutes. We want to put that into revolutions per minute. So that would be 1 revolution is 2 pi radians. And my radians now cancel each other out. 2 goes into 11,600, 5,800 times. Pi cancels out pi, and I'm left with this saw is spinning at 5,800 over 9 revolutions per minute. The only way that you're going to get better at this for Friday's test is by doing these. Okay? You have a tan worksheet from last week Friday. You have a white supplemental sheet from yesterday or Monday, whichever day you had class. Today you picked up a purple. Today you picked up a gold. Okay? You have plenty of things. There's assignments out of the book, okay, that you can be doing. On Friday, we will be collecting the 4.1A worksheet, which was last Friday's, that tan one. The 4.1B, which is the purple one you got today, and the gold one that you got today from those people that are below 85%. If you're above an 85%, the homework, turning in homework is optional. You should still be doing the homework, just the turning in aspect is optional for you if you're above 85%. Okay? And 85%ers above, if you ever fall below, then you become part of that. Just because right now you're above an 85% doesn't mean that you're exempt from homework for forever and ever. Amen. Okay? If you ever fall below that, then you become part of that. Okay? That's all I got for you. You have the remaining 22 minutes of class to work on whatever it is you need to work on, but it better be pre-calculus related.